Okay guys, today we're going to take a look at how to solve rational equations and partial fractions, how to decompose partial fractions. So first off, definitions. A rational expression is really anything that can be expressed as a fraction. So it's ultimately a ratio. It's something in the numerator over something in the denominator. Once we put an equal sign in there, once we have equality, we then have a rational equation, which is an equation with one or more rational expressions. And as we scroll down here, how do we solve these? Well, just like you did fractions in elementary school, we solve them by multiplying each side by the least common denominator, the LCD. And what that's going to give us is essentially a common denominator so that we can combine these things or work with them further. So let's take a look and see what that looks like. So in this first example here, I have 5 over x minus 3 is equal to 12 over 2x plus 3. So if I look at the denominators here, I don't see anything glaringly obvious that they have in common. So an easy one, or one that you can always be assured of, is if you multiply the two together. So what we'll do is I'll take x minus 3 times 2x plus 3, and I'll multiply that by the left side, 5 over x minus 3. And then I'll do the same thing on the right side. Now, we're able to do this again because our properties of equality allow us to manipulate an equation. As long as we do the same thing to both sides, we keep that equal. And I've multiplied both sides by the same quantity, so that's allowed. And now what you see happens here is that these common terms will cancel, and you're really just left with 2x plus 3 times 5. So when we condense this, I get 2x plus 3 times 5. That has to get distributed through, so I get 10x plus a 15. And then on the right side here, again, those two will cancel, and you get 12 times x minus 3, and we distribute that, 12x minus 36. And now this looks much simpler. I'm just going to go ahead and combine my x terms, and we'll rewrite. Add 36 to both sides. And I get 30, 40, 51. Divide by the 2. And x equals 51 halves. Simple as that. Let's take a look at another example. Okay, so let's take a look at this example. And again, I'm looking for the least common denominator. What do these all go into? And I see that all of these go into a 2x. So I'm going to use that. So I'm going to say 2x, that quantity is being multiplied by. Now I'll multiply it by the left side. And then I have the right side, and I will multiply this by a 2x. Now what begins to happen is if we do this all together, I would get, let's see, 10x over x minus, this gets distributed through, that is a 6x squared plus a 12x over 2x, and that equals 14x over 2. Now, I did this just to show you what you can really do is you can cancel out one of these multipliers in each. So the x would cancel here, the 2 would cancel here, or the 2x rather would cancel here. But if you do it and work it all out and just multiply to the numerator, same process, it just adds another step. But we'll go ahead and reduce everything from here. So 10x over x is just a 10. See, so we could have canceled the x's here and just had 2 times 5. And then I have 2x squared over 2x. Well, that goes in there, a 3 and an x. Again, that 2x would have just canceled here. And then 12x over 2x is a plus 6. And we see that again, first term's right there because the 2x canceled. I'm sorry, that's not an equal, that's a minus. And that equals 14x over 2, which is 7x. So now we've gotten rid of all those denominators, and we just have an equation here that we can rearrange and simplify. So we'll go ahead and combine our x terms, and we'll combine our like terms here. A 10 and a 6 is 16 equals 10x. We divide both sides by 10. And I get x equals, and I see here I can reduce 16 over 10. 2 goes into both. That would make it 8/5. And it doesn't look like it reduces any further. Okay, let's look at another one. So in this case, what we're going to look at is a common denominator. I see two of them are in common, and then I have an x. Well, I'm not seeing one that's glaringly obvious, so again, I'm just going to go ahead and multiply these two in order to create that common denominator. So we'll go ahead and multiply the left side by, use a different color, 3x minus 1 times x. And then over here on the right side, we'll multiply by a 3x minus 1 times x. Again, it's the properties of equality that allow you to manipulate this equation. As long as I do the same thing to both sides, it remains equal. And so I'm multiplying there, and I have 3x over 3x minus 1 plus 1 over x. And I'm multiplying that entire thing by that. And that equals, and this is 1 over 3x minus 1. So again, you see what happens here is when I multiply this through to this quantity, the 3x minus 1s cancel, and I have 3x times an x. So that's just going to be 3x squared. So boom, boom, 3x times x. And then when I distribute it through to this quantity, my x's cancel, and I have 3x minus 1 times the 1. And then here again, these cancel, and I have 1 times x, which is just an x. So now it looks like I have a quadratic going here. So I'm going to go ahead and set it equal to 0. So I'll bring this guy over. We'll go ahead and rewrite. So I have 3x squared. So 3x take away 1 is 2x minus 1. Then I'll check to see if I can factor it. That's going to be the easiest way to do that here. Again, I like to use the x. So I'll just go ahead and negative 1 times 3 is a negative 3, 2 in the bottom. Factors of 3 that make a 2, that's going to be a 1 and a 3. And because it's negative, one of them must be negative because they add to 2. I know that's going to be this one. And then if you want to, because this is greater than 1, you can go ahead and use the box method to go ahead and pull this out. Or you could use factoring by grouping. Doesn't really matter. I'll put the first term here, last term here, negative 1x and a 3x. Then we'll pull out the greatest common factors from these. So I can pull out an x and a 1. There's one of mine, and then a 3x minus 1. So there's my two factors, x plus 1, 3x minus 1. So then your solutions, your roots, your zeros here would be negative 1 and plus 1 divided by 3, 1/3. Same concept, we just ended up with a quadratic, so in order to finish it off, we had to factor. If it wasn't factorable, I could have looked to complete the square or use the quadratic formula, which we learned in a prior section. And let's look at this one. Now, first thing I notice here is that I do have a quadratic in the denominator. I always want to look to factor that out. And this is a perfect square, so I know that this is actually the difference of squares. So this is, if we rewrite it, is 2x over x minus 4 plus 10 minus 5x over x minus 4 times x plus 4 equals x over x plus 4. So again, pretty easy to see the common denominator. They all go into this. So I'm going to go ahead and multiply both sides by that. So this is going to be x minus 4 times x plus 4 times this quantity. And then again over here, this times x minus 4, x plus 4. And what you're going to see happen is that I take these to this term, the x minus 4 cancels, so I get x plus 4 times the 2x. So that's going to be a 2x squared plus 8x. And then to that, I distribute it over this way. The entire term cancels here, and I get 10 minus 5x. And then on this side, on the right side, my plus 4's cancel, and I get x times x minus 4. So that's an x squared minus 4x. So now we'll go ahead and combine some of these. Again, it's looking like I'm going to have a quadratic going here, so I'm going to take away the x squared, and I'm going to add 4x. We'll just do that in one step here. And then we'll go ahead and combine. So 2x squared minus an x squared is an x squared. I've got 8x's here minus 5x's is going to be a 3x plus 4x. That's a 7x. And then plus 10. So again, I'm going to look to factor. So I'll make an x. 1 times 10 is 10 in the top, 7 in the bottom. Factors of 10 that add to 7. Looks like it's going to be 5 and 2. Leading coefficient is a 1 in this case, so there's no reason to use the box. So I just have x plus 5, x plus 2. So then your roots are solutions. Your zeros are -5 and -2. Okay, look at one more here. So again, first step, I see I have this in the denominator, so I'm going to go ahead and look to factor it. So 8 in the top, 6 in the bottom. It's going to be a 4 and a 2, so this is going to factor out. Say x plus 4 plus 7x plus 12 over, looks like it's going to be an x plus 4 times an x plus 2, and that equals x plus 1 over x plus 2. So again, here's my least common denominator. They're all going into this. So I'm going to go ahead and multiply both sides. X plus 4 times x plus 2. X plus 4 times x plus 2. And then we'll go ahead and distribute this through. So in this first term, my x plus 4's cancel, and I get 2x times x plus 2. So that's 2x squared plus 4x. And then when I go to this term, the entire thing's cancel, and I have 7x plus 12. And that all equals, my x plus 2 cancels, x plus 1 times x plus 4, that's an x squared. This you have to FOIL out, or double distribute. X squared, there's a 4x and a 1x, so this is 5x. And then 1 times 4 plus 4. Again, so we're going to combine these, move them all to one side. We'll take away the x. Take away the 5x, take away the 4, so we'll subtract all this, minus the x squared, minus 5x, and a minus 4. Then we'll consolidate, we'll combine everything. Sorry, that should just be an x squared. So that's going to leave me with an x squared here. 4 take away 5 is a -1, but then I have 7 here, so that's a 6x. And then 12 minus 4, that's a +8. That all equals 0. Again, we're going to look to factor. 1 times 8 in the top, 6 in the bottom, factors of 8 that combine to a 6, that's a 4 and 2 again. So we're going to go ahead and have these terms of x plus 4 and x plus 2. So then your roots are zeros in this case again. Sorry, this should be a 2. Now, what you should notice when we just arrived at this ended up being the exact same value as what was in here. And you notice that if the values here are -4 and -2, what happens when these are put back into the equation? Yeah, you notice that when you sub in a -2 or you sub in 4s, what you're getting is zeros in the denominator. So that needs to trigger something. You kind of have to do a mental check here and actually say this one has no solution. We arrived at values that do not work given the constraints of this equation. When I put these into the denominator, this will error out. It cannot be done, so there is no solution for this problem. Now, the other thing we want to take a look at is partial fractions and how to decompose them. So one thing to remind yourselves first is, remember, you learn to add fractions together by finding the common denominators. Then you add the numerators over that common denominator. But sometimes we have a need for the application of actually breaking them apart into their pieces, and those are called partial fractions. So looking at this example first, we're going to go ahead and see how we combine these things. Then we'll look at how we actually break them back apart. So I have some quantity over x plus 2 plus 3, or any quantity over x minus 1. So in order to combine these two, I need a common denominator. So in this case, we would go ahead and make the common denominator the product of the two of these. So we'll go ahead and multiply them, just like, think of this as like 3/5 plus, if I needed to add this to, say, let's take something that's not 4/6. So in order to combine these two, I need that common denominator, a 5 and a 6. Well, that's going to be 30. I know there's one at 30. So what we do is, in order to increase this to 30, I multiply top and bottom by by a 6. And in order to increase this one to a 30, I multiply top and bottom by a 5. Now notice 6 over 6 is simply 1. So that's a ratio or fraction that is actually equivalent to 1. So when you multiply something by 1, we know it doesn't change its value. We are simply manipulating these in order to find a common denominator in order to combine them. So then this, in this case, would just be, 18 over 30 plus 20 over 30. And now I can combine. So that would be 38 over 30. And then you can look to reduce these. 38 over 30. I know that 2 certainly goes into both of those. 2 goes into 38 19 times, and here 15. And it looks like that's as simplified as it's going to get. And you can move it to a mixed fraction if you wish, but 19 over 15 certainly works for me. So again, in this case, we're going to do the exact same thing. So what we're really doing is multiplying them by a common denominator in order to produce a similar denominator in both terms. So in this one, what we're going to do is we're going to multiply this entire fraction by then on this side we'll have 3 over, and in this case we'll multiply this one by x plus 2. So it's the exact same thing, just slightly more complex as what you saw in our simple fractions. So again, we do this to the top. So in the top here, I have x minus 1 times 2, so that's 2x minus 2 over, and I'm just going to go ahead and leave these in a factor state. So I'll have x minus 1 times x plus 2, and that's going to be plus 3 times this, that's 3x plus 6 over x minus 1 x plus 2. And the reason I leave them as the factors down here instead of combining for this point is sometimes if we didn't quite find the lowest common denominator, there will be some reducing we might be able to do with these terms. But if I've already combined them or expanded it out, that makes it more difficult to see. So then we'll go ahead and combine these things. So I have a 2x plus a 3x, that's 5x. And then I have negative 2 plus 6, that's a plus 4. And then I have this as my common denominator. Now at this point, I'll go ahead and expand these out. That's an x squared. Then I have a negative x and a 2x, so that's plus an x. And then I have minus 2. So that's what this looks like once I've combined them. You have to get a common denominator that also affects the numerator in order to preserve the ratio. And then we just combined once they're common. Now in this next one, what we're going to look at is how to take it from there and actually break it back apart. So let's look at the example here. So we're going to take this quantity, and the first step here is we're going to take this and we're going to break it down into its factors. So 1 times 12 is 12, 7 in the bottom here, and then factors of 12 that make a 7, let's see, that's going to be 3 and 4. So I'm going to rewrite this then as x minus 4 over x plus 3 times x plus 4. Same thing, we just factored this out. Now, as we saw up above, how we make this is it's some value, we'll call this a, plus some value, we'll call it b, over these, x plus 3, x plus 4. So it's some quantity up here with this as the denominator combined with some quantity here plus this combined to make this. So we found that common denominator and we combined them. That's what made this quadratic. So it's something over this factor combined with something over this factor made this. So we just need to find what these pieces up top are. Now, in order to do this, we'll build this as an equation. So we'll just set this equal. So this quantity over this is equal to this part over that plus this part over that. So in order to find these two, what we're going to do is we're going to multiply them all by essentially a common denominator again, which would be x plus 3 times x plus 4. So when we do that here, for the sake of space, I'm not going to write it out. So we're going to multiply this all by that. So it will cancel, and we're left with x minus 4 and that equals. Then in this case, when I multiply this whole thing, let me show it here, times x plus 3 times x plus 4, it cancels here, and I'm going to get a. So my x plus 3 cancels, so I get a times x plus 4. I'm not going to distribute that out right now, and you'll see here in a second why. And then I get b, and when I distribute this to this term, x plus 4s will cancel, so I get b times x plus 3. So the reason I did that is it makes it easier. What I'm actually looking for is if I want to find a, I'm going to figure out what value of x here makes this 0, so b just goes away. So when I want to find a, I'm going to substitute a value in for x that cancels this out. And I see that that would be -3. So if I put -3 in here for x, you see this, that cancels to a 0. 0 times b, that goes away. So that's gone. And that equals -3 minus 4. So now I just have only one variable in here. I need to find the quantity of a. So I start to combine. -7 equals a, and -3 plus 4 is -1. So I divide both sides by a, excuse me, it's +1. -3 plus 4 is +1. So that's 1a. You can divide both sides by 1 if you want to finish that out. But what I know is that a equals -7. There's my first value. Now we'll go ahead and we'll find b. So we do the exact same thing. So I'm going to go ahead and go back up here a couple steps. Erase this. I'll rewrite. So I'm going to do the exact same thing. So I have x plus 4 plus b times x plus 3. Put the x back here. So now I want to find b. So now I'm going to cancel out this a. So what value of x is going to make this a 0? Well, it's going to be -4. So I'm going to go ahead and rewrite this. So I plug in -4 for all of my x values. And now we'll just condense. So -4 minus 4 is -8. A times -4 minus 4, or excuse me, -4 plus 4, that's a 0. So that cancels. And that leaves me with a b times -4 plus 3. -4 and 3 is a -1. I'll divide both sides by that -1. And b equals 8. So now what I found out is that this is actually comprised of -7 over this quantity plus 8 over that. And that is decomposition of partial fractions, or breaking them apart into partial fractions. So it's very similar. We just need to factor the denominator, break it apart, set it equal to some quantity, we call it a, over the first factor, combined with some quantity, we call it b, over the second. Multiply by that common denominator, least common denominator, cancels on the left side, sets you up like this on the right side, and then we just find essentially your zeros. Substitute the value in here that makes it 0, solve. Substitute the value in here that makes it 0, solve. So that's it for decomposition of fractions. If you have any questions, bring them to class tomorrow and we'll get a little more practice.